Now we move to a few aspects that we need to consider when we do this strength test. First is consideration is on the loading rate, with the strain rate. Okay, the higher of the loading rate, the lower of strength. This is very important. So mean that if you do this fastest rate, so the same material compared to slow rate of loading is give you different strength. So it's recommended ISRM recommended between 0.1 to 0.001 millimeter per second. Okay, so degree of saturation. So normally test under saturated conditions. So this is very important. So you have to soak your samples and in water. So third, your flatness and smoothness of a specimen. So make sure if your cell specimen in the course like this, so you make sure this bottom here and up top here must be flat. And then because the end condition of contact between sample and loading plate must be net surface finish of sample and pattern of pattern. Okay, this is very important. So smooth flatness and smooth. A specimen must be smooth, the specimen, and then must be straight, and then effect of different end condition H over T ratio. Okay, means here the diameter, the diameter and the length here, the height and diameter ratio must be more than 2. Okay, now we discuss on parameter that affecting the laboratory testing results. So standard testing and sample preparation must be follow the standard ISRM, and this we want to minimize the factor affecting our results. So meaning that everybody have their similar procedure. So environments, so look on the temperature and humidity. The specimen size must be specified as recommended. When discontinuity include the sample, so the core sample of classic sample. Okay, so it's depend on the discontinuity and the shape of samples. Okay, H over D. Okay, diameter and height of sample is influence your parameters of laboratory testing. So this sample diameter, if we alternate compressive strength decrease when the sample increase in sample height. If you have high and low length diameter, sorry, this is sample diameter. If you have larger size of diameter, so sorry, it decrease in sample. Okay, sorry, high. We will not discuss about that. Or we discuss about high. If you have high here, another high here, shorter than longer. So if you have shorter high, so this one the ultimate compressive strength is higher, but here longer is lower strength. Okay, that's why for H over D is greater than 2 remain constant, but the recommended H over D is more than 2 technical size effect. So it's recommended is 1 here is and 2 here. Okay, it's ratio 1 over 2. So and condition also affect the ultimate bearing capacity, ultimate compressive strength. Sorry. Okay, stiffness and compression machine use. So loading column or machine equipped with closed loop servo control loading system can reduce sudden violent post failure mode. Okay, this is very important, the equipment that we use. And then the state of stress, relic stress in the rock mass affect the strength of rock. So depend is the location of samples of rock. So normally it can affect the strength of rocks. And then the most the above effect cannot be eliminated but can be minimized through the standard procedure or SRM. So that's why we have the standards of procedure. Yeah, so we can able to minimize the unnecessary problems. So discontinuity in rock may affect their strength. To discuss this issue, so normally the strength of rock material with the compressive, tensile, shear strength, and all other properties is affected by this discontinuity. So depending on the scale being considered in strength, the rock is affected by presence of discontinuity. So depend on the strength of the sample. So the most important effect, so this discontinuity is the most important effects in the strength reduction. So for small laboratory samples, it is affected by mineral arrangement. For large scale, rock mass is affected by geological structures. Normally, it's like bedding plane, joint, or faults. And the laboratory testing is important to note the direction. So if we do this testing, we need to identify where is the loading direction towards the discontinuities. For example, this study, the strength reduction depend on loading orientation with respect to discontinuity plane. This is a discontinuity. This is viscous. This is example of schist rocks. This is schistose foliation. This foliation. This shows the direction of load. Okay, this error. So meaning that here, if we have these directions of these foliations, this horizontal, this vertical foliation, or in inclined positions, shows that the in the horizontal direction of foliation perpendicular to slope direction is give you the high strength and higher strain compared to C here. It's also give quite high strength but low strain, because it's easily to split because of this direction of foliation, so very low strain. But in terms of this direction, so because the incline, so it's quite very low, quite low their stress, then and then the strain is a bit high compared to the C direction. In terms of scale effect, size samples, so if we have a jointed rock mass like this, normally intact rock is intact rock without any discontinuity effects to these few numbers of discontinuity, for example single, several discontinuity and rock mass. So depend on the size. So strength of rock mass more appropriate assess using in situ large scale testing. So this is how the discontinuity affect the strength of rock. So So this is the influence of discipline on strength. Example, joint orientation with respect to loading exists. Okay, this loading exists. So the effect of single joint and multiple joint under different inclination of inertial compressive stress. So this is angle of fracture. This is fracture. This is our fracture doubles. This is multiple fracture. So if we have a low angle, normally fracture is low angle is 0. 0 is like this. If vertical like this, higher is 90 degrees. In between here is between 0 to 93. So it's between 0 to 90 is in the middle here is 45. So it's 45 somewhere here. So in case 1, with increasing of this angle of fracture up to certain 45 degree, the strength is reduced. But and then after that the strength is increased if we have degree of fracture is up to vertical, so back to this position. If we have a pair of discontinuity, so the reduction of strength is quite significant in terms of strength here. If we have this little bit increase in strength in an angle, so the strength is reduced. Okay, this is 0 degrees, 45 somewhere here. So mean that if we have maybe 20 degrees is already reduced this strength. But if we have multiple discontinuity, so the strength is reduced significantly, and then that's why in the case if you measure intact rock, normally is very high strength, but for rock mass normally the strength is reduced because we have influenced by discontinuity. So for next chapter we will discuss of rock mass, so you able to differentiate between rock mass or intact rocks. So that's all for rock testing. Thank you very much for your attention.